Molar conversions limiting reactants. This is the most challenging type of molar conversion typically, and what is going on is you're given random amounts of each reactant. For example, in this case, we're burning 100 grams of magnesium, but we only have 100 grams of oxygen. How many grams of magnesium oxide will we produce? Well, what you need to figure out is what you have too much of and what you don't have enough of. A great way to do this is with a reaction table. Start by writing the balanced chemical equation. We're reacting magnesium with oxygen to make magnesium oxide. Now I've taken the liberty of balancing it. 2 magnesiums, 2 magnesiums, 2 oxygens, 2 oxygens. Great, it's balanced. Determine the molecular weight of each substance. That's not that hard. Look it up on the periodic table. Then you have your molecular weights. You're given how many grams of each one that you are reacting, and recognize this problem. Sometimes they'll say 100 grams of magnesium with excess oxygen. That's not a limiting reactant problem. There's nothing that limits it. You can just go and make the complete amount. For this one, you have to figure out the moles of each. This looks like a little bit more than 4. This looks like a little bit more than 3. However, let's check it out. Every 2 of these requires 1 of that. No problem. 4.1 would only need 2.05. We have excess oxygen. Similarly, 1 of these requires 2 of these, and we don't have that. We would need 6.2, and we only have 4.1. Clearly, magnesium is the limiting reactant. Oxygen is the excess. And let's go ahead and fill out the rest of this calculation. We've done this before in other questions, but let's see. 2 of these will make 2 of those. So we should get 4.1 moles of magnesium oxide. And if 40.3 grams is a mole, I guess we have better than 160 grams, which we could make. And so we'll make 165 grams. There's some oxygen that is left kicking around, and the hardest question is typically how much oxygen remains. Well, we started with 200 grams. We have 165.3 accounted for. We've answered the question to the first part, how much oxygen remains? Well, the rest, right? What is that? 34.7 grams. I can't begin to tell you how much time this saves compared to a textbook system for doing this. You do 2 3-steppers, and then you have to do this logic part to determine how much oxygen remains. Although it has some clarity to it, it's very time consuming. I typically say I only have time to write 1 of these per test, but if you use this method, you might be able to do it in half the time. This is a limiting and excess reactant problem, and for our next topic, we will cover percent composition.